good morning everyone. Today our group would like to discuss about our SL group work, which consists of 8 questions, but we are supposed to choose only 2 questions only. So before that we go through further, I would like to introduce my team members. Okay, so my name is Muhammad Shami bin Mukhtar. My metric number is 181 and 964. So
my name is Muhammad Ggwp bin Hauzi. My metric number is 182318.
My name is Ggwp. My metric number is 181677.
And actually we have 5 members each team, but the rest have the class, but they have contributed that there are only 5 or 6 members, but we only choose 5 members, but the rest, the 2 team members are having classes. So however, they have contributed something with this work, so never mind, we just go through with the presentation. So let's go through the
first
work
question.
Okay, first question. So question 1, before that we have choose question 1 and 2, so let's move on with question 1 first. So let's look at the question. Let me read. The material used to build top and bottom of a rectangular container costs $10 feet square, and the material used to build the sides costs $6 feet square. Note that its base length is 3 times the base width. If it sets that its volume is 50 feet cubed, determine its dimensions that minimize the cost to construct it. So the question told us to find the minimum cost to the minimum dimension to minimize the cost to construct it. Okay, so we have come up with these operations and syntax, not syntax. Okay, so first we just imagine, let's look like a box here. So we have a box like a cube. We just imagine that the shape looks like this. So the base length is 3x times base for the width. So we have assumed that 3x and x. Okay, and the height, which is h. So the volume has been told that is told us 50 feet cubed. So we have come up with this formula. Volume equals to 50 equals to 3x squared and h, because we have 3x times x times h. So we got this answer, or this output, 3x squared plus 3x squared h. Okay, so let's move on to we have to find the area. So area we have come up with this 6x squared plus 6sh plus xh plus xh. We got 6x squared plus 8sh. So actually it's quite simple. We just find the base, the total sides. So we have 3x squared for the bottom,
for the
base, and for the top. So we got 3x squared plus 3x squared. We got 6x squared, and plus 6sh from this 3xh. We have 4 sides. From these sides, on this side, on the back side, and from this side. So we got 4 sides here. 1, 2, 3, and 4. So we got 6, 8. Plus with at the top and the bottom. So we got this. Okay. The third step is we have to find the height, because we don't know what is the height. So we just settle with this. We need to find the height, so we just take the volume from the formula of the rectangular cuboid with this, just to find h. We will do like this: 50 equals to 3x squared h, and 50 over 3x squared equals to h. So that's okay. So this is the h, and then let's assume that we don't know the answer. So we just move on to the 4th step, which is 6x squared plus 8sh. Okay, so I just take it from here and substitute with this value. Since we have known the h, we just substitute h with 50 over 3x squared, and we got this. So this is for the a. Right?
Yes.
Okay,
Yes.
so same, just the same. However, we have to find the minimum cost. The minimum, what you say? The cost of the construct. So we have to find first derivative, or we just differentiate this one and this one. Yeah, same. Okay, we just differentiate. We got how to differentiate 6x squared? We just got 12x. Supposed to be plus. And 403x squared, right?
Yes.
And equal to 0. Why? Because we have the formula here. If we want to find the max and minimum point, we have when f first derivative equals 0, the second less than 0, it will be maximum. If the first derivative we got equal to 0 and the second derivative is more than 0, we got the minimum point, the minimum value. So in this, we have to find the x. So we just come up with this formula, with this operation. So we just differentiate, we got a prime, or we can write dA dx. Okay? Just the same. So we just equal to 0 and then find the x. So we got 12x equals to 400 over 3x squared, and then 36x cubed equal to 400, and then we just got the final answer, which is cube root of 11, 1 and over 1 over 9. So we just got x, and then we have
we determine the second
derivatives to check whether it is minimum or maximum. Okay, so we just move with this, just got 12x. We differentiate once again, the second time, 12x. Okay, this is first, second, right? Is this correct?
Yes.
Okay.
Yes.
Okay, substitute the x.
Inside the second.
Then we got the x here, and then we got the value. So 36 is more than 0. So we can check from the formula, is it more than 0? So which part is it minimum? So we just go to the last step, which is substitute the x, the x value, okay? 3x, okay, 50 over 3 times with the x squared equal to h. So now we have got the h. So 3 times 3.341716 equal to h. So
And to check if both of the answer is correct, we substitute the value x and h into the first equation to get the volume, and we get 50.
yeah,
50.
not very 50, but the
49.99.
approximation is 49.99, something like that. So I think that's all for
Question number
one. It's quite tricky, but it's long. It's quite complex, but we have to reduce the operation into numbers so we can easily analyze what are the steps that are going to be that are suitable to take to get the final answer, which is this value for the h. So that's the minimum cost.
We know question number 2. Question number 2, we have to find the maximum volume by using the 10 meter square of area. So now, here I have the formula for the volume, which is the bottom width times the length, which is the same. So I use R for both. So R squared times height is the h. So and then this is the formula for the area. This is a 2R squared, which is the top and the bottom of the box, and 4HR, which is the four side of the box. So let's find the h first. So we simplify everything here, and then we got h equals to 10 over 4R minus R over 2. So okay, that's the idea. And then we substitute this h inside this equation. So we substitute, and then we R squared times this equation, we get this. Sorry, this one R squared is inside. The R cube is inside here. Okay, and then we differentiate this one, and then we get this one. 10 over 4 minus 3R squared over 2. Because then we make it equal to 0, because we have to find the critical point, which is now we should determine the maximum volume. So then we just make it equal to 0, and then last we get R equals to root 5 over 3. Since this is a volume, there's no way this could be a negative, so we take this as a positive value, and R is equal to 1.2999. Okay, then we take this R, we substitute back into this equation. This one, and then we will get h is equal to 1.29099. Okay, then we try to prove whether this one is same, and if this h and r is suitable for this equation or not. And then we will get 2 times root 5 over 3 square plus 4 times root 5 over 3 times root 5 over 3. So actually this root 5 over 3 is equals to 1.29099. So we get 2 times 5 over 3 plus 4 times 5 over 3. So we get 10. That's all for number 2.